Alright, okay, we're going to put the whole thing together now. So here's a equation. So we're going to try and find the centre of curvature, which means that to start with we need to find the radius of curvature. And to do that we need to find the first and the second derivatives. So the first derivative of this thing looks to me like a quotient rule. So the derivative of the top one times the bottom one minus the top one times the derivative of the bottom one all over the bottom one squared. Let's try and simplify this thing down a wee bit. So what have we got? We've got 4x, and then we've got 4 minus 4x, so no x's, that's quite convenient. Minus 12, negative 12, and then we've got positive 11, so that's going to be minus 1, which I think I'd probably like to write as negative 3 minus x to the power of negative 2. Could be quite a nice way of doing it. And we're trying to evaluate that at the point where x equals 2, so at the point x equals 2, dy by dx equals 3 minus 2 is 1, 1 to the power of anything is still 1, and negative. So the first derivative at the point we're interested in is negative 1, and the second derivative is going to be, let's just differentiate this thing because it's the easiest way to do it. So bring the power down the front, drop the power by 1 and multiply by the derivative of the inside thing. So that's all quite nice and straightforward. And at the point where x equals 2, that's going to be the second derivative is going to be again 2, so 3 minus 2 is 1, still 1, times 2 is 2, negative. So that's all very nice. So the second derivative is negative 2, and then we can plug this into the formula for the radius, which is 1 plus the first derivative squared to the power of 3 over 2 all over the second derivative, which gives us 1 plus negative 1 squared is 1 to the power of 3 over 2 all over negative 2. So that's 2 to the power of 3 over 2, which is 2 root 2 over negative 2. So it's negative root 2 is the radius of curvature. And so that's relatively nice. So the circle is going to have a radius of root 2. And then we can use that to work out what's going to happen for the centre of curvature. So the first thing to find for the centre of curvature is we need to find the angle. So we go tan theta is dy by dx evaluated at p. So in this case theta is tan inverse of dy by dx, which is tan inverse of negative 1. And depending on how good you are at your trig functions, you might as well do it on the calculator. It's quite a nice one, but we'll do it on the calculator. So it doesn't really matter whether we're in radians or degrees, because we're going to use a sine and a cosine, so we're going to put it straight back in again. So my calculator happens to be in degrees when I pick it up. So tan inverse of negative 1 is negative 45 degrees. Okay, so we know the angle is negative 45 degrees. So then we just go, which is x1 minus r sine theta. So our x value was 2 minus r, which is negative root 2, times the sine of negative 45 degrees. Okay, and we can pump all that into a calculator. So we go 2 minus negative root 2 times the sine of negative 45, and it all comes out to be 1. Okay, so the x-coordinate of the centre of curvature is 1, and then we repeat for the y1, which the formula is k equals y1 plus r sine theta. Y1 was 3, we were told, plus r, oops, I've got my cos and sine, this one's a cos, not a sine, isn't it? Cos negative 45 degrees, and again we get the calculator, so 3 plus negative root 2 times cosine this time of negative 45 is 2. So this is the centre of curvature. So the centre of curvature is at the point 1, 2, and the radius is square root of 2. So if we were to create the circle that fits just inside the curve, then the circle would be x minus 1 squared plus y minus 2 squared equals root 2 squared, which is 2. Okay, so that should be the circle we're looking at. So the radius of that circle is equal to square root of 2, and the centre of that circle is at 1, 2. Okay, so if we draw a graph of this equation, then and that circle, then at the point 2, 3, they should just neatly fit inside each other. So let's have a go and see if it works out.